friends, welcome to my channel. I hope everyone is doing good. Today we are going to solve a very recent problem on Leetcode 3633 earliest finish time for land and water rights 1. So another interesting problem on arrays, and this is also a very recent coding problem. So I would like to discuss this problem with you guys. I created some nice examples also so you can clearly understand the logic as well as the solution to solve this coding problem. If you are new to this channel, please subscribe to this channel now. It really helps and supports this channel. So let's start with the problem statement. You are given two categories of theme park attractions, land rides and water rides. So land rides has a land start time and land duration basically, right? The earliest time ith land ride can be boarded and ith land ride last, right? And same thing you will have for water rides. So water start time and water duration basically, correct? So two types of rides are there. Okay, a tourist must experience exactly one ride from each category and neither or in either order. Okay, so you can experience in in any order, right? Order doesn't matter. They are saying a ride may be started at its opening time or any later moment. Okay, if a ride is started at time t, it finishes at time t plus duration, because we know the duration, right? Immediately after finishing one ride, the tourist may board the other ride if it is already open or wait until it opens. Okay, return the earliest possible time at which the tourist can finish both the rides. So this is what we want to find out, the earliest possible time at which the tourists can finish both the rides, right? Water ride and land ride. So this is what the problem statement says. We'll understand it more with some examples. M and N are number of elements in that array, and maximum 100 numbers will be there in that given array, and the numbers will range between 1 to 1000 inclusive. Okay, so let's take a look at this first example they have given us, right? So here the earliest you can finish, one can finish, is if you start a land ride at 2, right? And your land ride will last for 4 minutes, let's say, right? So 2 minutes you started at 6th, 4 minute means 6th minute you finished, right? So land ride you finished at 6th minute, and you are taking the water ride at 6th minute, and it will last for 3 minutes. So at 9th minute earliest you can finish both the rides in this example. Okay, so why we are not taking 8 and 1? Because it will not give us the earliest time, right? Because 8 plus 1 will be 9, and then you will again have to take that water ride for 3 minutes, so it will be 12. So it's not actually earliest possible time. That's why we have chosen 2 and 4 here, right? 2 and 4, because we are interested to find the earliest possible time when you can finish taking both the rides, right? So this is one example they have. The other example here is this one. So here land ride starts at 5 and it lasts at for 3. So and water ride start at 1 and it goes until like 10 minutes basically, right? So it means that if we take water ride first, so it will finish at 11th minute, right? 1 plus 10, and then I can take the land ride, right, for 3 minutes. So 11 plus 3 is 14. That's what we will get here, correct? What if I start at the land ride first? Then it will go from 5 to 3, so it means 8th minute, and then I have to take this ride, so it will be 18 minutes. So it's not earliest time, so the earliest time will be 14 minutes. So you must have recognized by this time that we have to basically try both the times, right? Both from both the sides. I mean to say that we want to first we have two choices here, right? You can take a land ride and then water ride, or you can take water ride first and then land ride, correct? So both choices you have to try, right? So this is another example I created for you guys. Okay, so in this case, so let's understand this with our approach also, so it will be clear. So let's say we are taking a land ride first, right? So first we are taking land ride. So what happens if I am taking a land ride? Okay, so I will take this land ride 3-1, so it will be finished at 4th minute, right? This is the earliest I can finish. Why not this? Because this will be later, right? 12 plus 1 is 13. 2 plus 6 is 8. So that's not what I want actually. I want to finish earliest. So I'll take this one, right? So it will be finished at 4th minute. And then after that, I can take this ride, right? Uh, it will be, yeah, 4th minute, and then I have to take this ride, right? This ride I can take. Why I'm taking this ride? Because it's already open now. I can finish it 10 more minutes. So at 14th minute I will be done, correct? 14th minute I'll be finished, correct? If I take this will, I have to wait until 6, but and then again I will take this ride 8, right? So it means that again 14 minutes, right? 8 plus 6 is 14. So 14 minutes you will finish if you start taking a land ride first. So this you understood, correct? Okay. So other thing is I can take the water ride first, right? I will take water ride first. So let's consider this scenario now, water ride. So which one should I take in these two? There are two options I have. So obviously I will take this, right? Because this finishes early. This is important, right? This finishes early. This will finish at 12. This one will finish at 14. So I want to finish early. Okay. So I'm taking this 12. After this one is done, I will take this one. Why? Because this one is available at this time and it takes only 1 minute, right? I can take this also. Both can actually, anything I can take, and it just takes 1 more minute. So I will be finished at 13th minute, correct? So it's beneficial, right, for us to take water ride first. So we'll take water ride here first, and the answer is 13 in this case. So now you understood that we have to calculate both sides, right? First take land ride, then water ride, or first take water ride and then land ride. And then whatever is the minimum, you have to choose from it, correct? So that is the basic approach that we will use to solve this problem. So I think we can directly go and I'll explain you through the Java code, but I think you got the idea. And when we are picking up, we will pick up the water rate that will finish first, right? So we have to keep track of the minimum so that we will know when it is finishing, which one is the finishing first, right? So that we can, because why? Because we want to find earliest finish time, right? So that's why. Okay, so let's go to the Java code. I'll explain you more there. So we'll first create one static final. It's infinity, which is integers max value. We'll use that for initialization. N is the size of the land start time, and M is the size of the water start time, right? Because this array can have different sizes. So we'll just got that sizes here, and we created 4 variables: land, water, and land underscore water, and water underscore land. All will be assigned infinity value, right, in the beginning. So what land underscore water means? It means that we are taking a land ride first and then water ride. And what water underscore land means? We are taking first water ride and then land ride, right? So let's take a look at this for loop. So we are actually iterating through the land array, and then we are finding out the minimum value. So what is the minimum value of the start time plus duration, correct? So that we can find out the earliest finish time for land, right? Earliest finish time for land ride. Okay. So this one you understood. So land is earliest finish time for land ride. Similarly, water is earliest finish time for water ride. So now once we find out the earliest finish type of land ride, then we can also calculate now the earliest finish time if we are taking a land ride first and then water ride, correct? So that's what we are doing here. So here we are actually finding the minimum time of water ride, which is the earliest time of water ride, right, which it can finish. But at the same time we are also calculating the land water. So land water, it means that we are taking a land ride first and then water ride. So how we will calculate that? We will take first, here we will calculate the maximum between the water start time and land value that we found here, which is the minimum value, right, when the land ride can end. And then you will add the water duration. So why we are doing this maximum? Because you can only take that water ride after you finish the land ride, right? For land water, you understood this, right? You can only take water ride once you finish the minimum, that land ride. Okay, that's why we are calculating the maximum. So whatever is the maximum, you will choose it, right, so that you can actually take that ride. And then you will have to add the water duration it, and then you will keep track of the minimum value you find, right, because you want to find out earliest finish time. So that's why we have to keep track of the minimum value. Okay, so land water is one thing. So in this case, land water is 14. This thing is a land water thing, right? Where you are taking a land ride first and then water ride, correct? So that is 14. This one is when you are taking water ride first and then land ride. So this one we will calculate now here. So this part you understood. Here we are done with the calculation of first taking land ride and then taking water ride here in this land water variable. So we already know that, but now we have to also consider the other choice where you are taking a water ride first and then land ride, right? So this is what we are calculating here. For that you have to take a maximum between land start time and water. Why? Because now you are assuming that you actually are, you can only start after you are done with the water ride, right? So it means that you have to take the maximum between these two values, the starting time for land ride and water, right? Because you can only start this ride after you finish with the water ride. Okay, you understood that, right? Okay, so take the maximum of it and then add the land duration to it, and you will take the minimum of this value in water land, right? Because you want to take earliest finish time, so you will keep track of the minimum time. So at the end you know both the variable values. So what these variables values are telling us, so land water will tell us that you are taking a land ride first and water ride, and what will be the minimum value for that. That is what it tells us. And what is water land tells us, water underscore land, it tells us that you are taking a water ride first and then land ride, and what is the minimum value of it, right? Okay, so both minimum values you found, you take minimum of them, and that will give you the earliest finish time for land and water rights. So that's pretty much it as the code goes. I hope I explained it correctly and well, so that you understood this concept of how we have taken these both choices to find out this. And I already explained you through this example. So now is the time to calculate the time complexity and space complexity for this code. So because of these for loops, this is n times, this is m times, and this is again n times. So you can just say it's order of m plus n, because these are different for loops. Okay, so that's how you can explain the time complexity. And the space complexity for this code is constant. This is a constant on space solution. Why? Because we did not really use any data structure to store any information here, right? So we didn't use list, hash map, hash set, nothing, right? So it's just couple of variables, and variables, they do not count over space. So it means that this is a order of one or constant on space solution. Okay, so let's give it a run, make sure this code compiles and runs correctly. So as you can see, the code is accepting the test cases. So here we are getting correct results. So it's working correctly. We'll submit this now to the Leetcode, make sure the code gets accepted by the Leetcode. And as you can see here on the left side, it's accepted on 100% on performance, which is a pretty good solution to solve this coding problem. 36:33 earliest finish time for land and water rights one. So I hope this explanation and this code explanation helped you understand this problem clearly and how we have solved this problem with these examples. And if you like the way the video is created with these customized examples for you, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. Your subscription is very valuable and important for the channel. It really helps and supports the channel. It takes a lots of efforts to create these videos, to come up with these examples and to explain these examples. So try to be generous, and if you really think that this video helped you understand this problem in a clear and clear way, then please give it a like for this video, subscribe to our channel, and click on the bell notification icon right away, so you won't miss any upcoming interesting videos that we explain about different coding interviews questions. The important playlists for you on this channel are graphs, matrices, binary search trees, binary trees, problems related to binary search, dynamic programming, recursion, memoization, how to use and apply BFS and DFS on graphs, matrices, binary search trees. Different data structures related playlists are also important for you, that include stacks, queues, priority queues, min heap, max heap. So go through those playlists. There are more than 550 solved problems for you, and those problems are previously asked questions by FANG companies as well as other big companies. So they will definitely give you a good preparation for your interview rounds and will help you learn more Java as well as programming. Keep learning, keep coding, keep solving more varieties of coding problems, and thanks for watching this video and have a great day ahead.